I hope the slides dah sampai lah dekat email.
Okay, semua slide and then juga download link. Saya dah forward to all participants paling lewat pun last night. Yang earlier registration tu I've already forward to them 1 or 2 days before lah.
Yang tadi punya slide boleh share dekat chat box.
Oh, okay, yang tadi ya.
Yang dua tu.
Okay.
Kat sini dia tak boleh share.
Boleh. Nanti saya download dulu. Prof email saya, Prof.
UNT.
Tak masuk pun. Okay, dekat spam.
Yang satu lagi email Yahoo lah.
Yahoo ada. Yahoo is liza1977@yahoo.com.
Tak, email ada kan?
empty email ni kadang-kadang kalau weekend dia tak masuk inbox.
Saya hantar kat Yahoo.
Sekejap lagi. Okay, baru dapat.
Okay, good morning. Welcome to this two-day workshop on Smart PLS. Thank you, Dr. Yus, for organizing the session. So what we will do is the first half of the day, or maybe until lunch, we will be talking about the theoretical part before we start looking at hands-on. So I hope you have already installed Smart PLS 3.3.3, SPSS, and also Excel, so that when we start the hands-on, you will not have any problem. Huh? The license key I will provide you a bit later, so that when everybody joins. At the moment, I think we have another half the class not in the session yet. No? Okay. So my name is Ramaya. I've been at the School of Management for 31 years now. Hopefully another 3 more years before I retire. I've been doing this workshop quite some time now. But one of the problems with many of this software is each software will have its own limitation. You need to understand those limitations, because what I see is many instructors will tell you that is the best software every time they do a workshop. I will not be telling you this is the best software. There are some limitations with the software you need to understand. There are also many better software available, but they are a bit more difficult to master. So that is why many people prefer the software called Smart PLS. Okay, and why this mastery of tools are important is, as a research candidate or an academic, you need to write papers, research papers, and publish the papers. So one of the requirements for a good research is rigorous analysis and robust reporting. So those are important, but you don't get published because of the analysis. You get published because of your idea. So the first thing you need to understand is good papers are published based on the idea, not about analysis alone. But if you have good analysis, then you're halfway. So that is the reason why you need to understand the different tools available for you to use. Okay. And these tools will change over time. I think when I first started way back in 1990, most of us use only SPSS. But as we progress along, you see some changes. People started to move to structural equation modeling using AMOS. And then now we have structural equation modeling using partial least square set. Okay, so you need to somehow get some knowledge about all these tools available before you start applying them in your own business. Yeah? And you have to also do some homework. What I find is many younger researchers now, they don't like to read. What they want is somebody to tell them what to do. Then you become like a research assistant. For the rest of your life, you will be dependent on the person who's giving you the instruction. As part of your research career, you need to also read books and journal papers. Books are normally written like 5 years back. They don't get updated every year. But journal papers will get published every year. So most of the changes happening in the literature you get from reading journal papers. So I will give you some materials to start you off. You can look at them and then decide which path you want to take. Okay, so those are some of the materials I'll be sharing with you a bit later. So at the moment, before the start, I will like you to focus on this. I think many people have listening problem. No? Most of the time, you're not listening to understand. Most of the time, you're listening to reply. That's a basic problem. So the slides, the recording and all will be given to you later. You don't have to ask because what I see is before the start, you're already focusing on the slides and the recording. You attend workshop to listen, not to get the recording and the material. That's the first thing you need to understand as a participant. Okay. And some of the things I discussed, they are not in textbooks. So those are from some of my experience over the 30 years as a supervisor and also as a researcher. So listen a bit more carefully. We will have a break 10:30. We will have another break about 12:30 and another break at 3:30. So we will have 3 breaks altogether. So you will have enough time for rest and also enough time for some hands-on. Okay. My structural equation modeling journey started way back in 2008. Before 2008, I did not do any structural equation.
Prof,
Yeah.
Pak Munawar, can you mute yourself? Prof boleh buat macam saya co-host tak? Or anyone help you so that saya boleh bantu mutekan. You can make myself as co-host so that Pak Munawar dengan Prof Aminullah, please mute yourself if you do not have any question.
Baik, siap, Prof.
Okay, Prof.
Masa break lah.
Boleh.
Okay, my structural equation modeling journey started in 2008. Before 2008, I only used SPSS. And what happened was 2007, 2008, many of the papers that I submitted to good journals were actually written by the editors saying that can you reanalyze using structural equation modeling. So that is one of the reasons why I thought I should start picking up on this technique called structural equation modeling. So in 2008, what I did was I traveled to University of Connecticut to meet a guy called David Kenny. David Kenny, most of you will not recognize him, but he's the he wrote a paper that we will cite a lot called Barron and Kenny 1986. So this is the guy who wrote the paper Barron and Kenny 1986, which has more than 100,000 citations. Okay, 100,000 citations. So he's considered the legend in mediation. In 2008, I wanted to learn structural equation modeling. Then I saw an advertisement from the University of Connecticut on structural equation modeling using AMOS. So that is the first trip I made to US. It took me 33 hours to reach US. I took a flight from Penang to Changi in Singapore. From Singapore, I took a flight to Frankfurt in Germany. From Germany, another flight to New York, okay, which is quite a long travel time. And then from New York, I took a train to Boston. From Boston, I took a bus to Hartford. From Hartford, I took a taxi to University of Connecticut. So 33 hours spent traveling. One day I was sleeping, and then I spent another 4 days with David Kenny. And we see he took me for lunch because there were 40 people who attended the workshop. I was the only one outside from the US. The 39 people were all from US. I was the only one traveling all the way from this part of the world. So that is the reason he took me for lunch. In the West, lunch is not provided. And this is a workshop they charge 900 US. Okay? 900 US. But they don't even provide lunch. That's the arrangement they have in the West. So although I attended this workshop in 2008, some of the things I wanted to learn, I could not learn from this workshop because David Kenny is from an area called experimental psychology, not business and management. So that is one of the reasons why some of the things I wanted to learn, I could not learn from this first workshop, although it was an interesting eye-opener. But I actually went to the next workshop to learn a bit more about this technique called structural equation modeling. The second trip I went to the US was in 2010. This time I went to visit this guy called Gregory Hancock at the University of Washington. This is a software called Lizrad, which is a competitor to the software called EMOS. So EMOS and Lizrad, they are actually the same level of software called covariance-based set. Okay, so now we have two variation to structural equation modeling. One is called the variance-based SEM. The other one is called the covariance-based SEM. Both are competing, but the one very popular now is the variance-based SEM. But this is a very, very powerful software, but it's slightly more difficult to master because you need to know programming. Okay? We call it syntax. Okay? You write the syntax, 100 lines of syntax, and then you compile the syntax. If there are no errors, then some output will come out. If there are errors, they will tell you there is error in line 38, there is error in line 48. You have to go and correct the error before you can get some output. So those are the kind of software also available until now. They are more powerful, but a bit more difficult because many people are not programmed to write coding. Okay? To write coding. So this is why I attended this workshop, to see the comparison between a software like EMOS and another competitor software called Lizrad. Okay? I have not used this software in any of my papers until now. Okay? Although I attended the workshop in 2010, the problem is writing the syntax. You have to read down, sit down and write 100 lines of code. So that's one of the problems most of us have. We prefer where we can click. So that's the one we like to do. The third workshop I attended was in Australia. Okay, in Australia. This is a workshop organized by Everada Cunningham. This is a workshop organized by a group of consortium in Australia called ACSPRI. ACSPRI. They do this every summer and winter. And they offer a research method workshop, data analysis workshop, mixed method, qualitative, quantitative, M+, AMOS, those kind of workshop. But they charge a lot. No? This is a workshop where they charge 2,300 Australian dollars for a 4-day workshop. They have 3 days workshop, and the last day you can have 20 minutes one-to-one with the instructor. And this is one of the best workshops I've attended ever in my life, no? In terms of explanation and also the materials. The materials were really good at that time, no? Okay, but now they have also a lot of changes. But 2010, no? This was in 2010, we were already discussing about this issue called formative versus reflective measurement. Okay, and now we are already in 2021. Many people are still doing what we call as reflective measurement, although there's some changes in the measurement. So you need to understand for measurement now we have formative and reflective. Most researchers have been trained with this measurement called reflective because most software can only do reflective. Okay? Only now, more recently, there's some development into formative level of measurement. So that was my third workshop to understand better this technique called structural equation. Now, in 2012, I started meeting this guy called Joseph. This is a guy you cite in your papers by the name Hare et al., right? I've been citing him from the 1990s. One of the good things about him is his books are really easy to understand, quite straightforward, not much of formulas, okay, easy to understand. In 2012, he came to Malaysia for a workshop, for a conference, and then he did a workshop on AMOS. Okay? Although the workshop didn't go very well, but his keynote speech was really good. Okay? That was in 2012. In 2015, he came again to Malaysia for this conference, ICSSBE 2015, the second one. Okay, this time he organized a workshop on partial least square SEM. So now for partial least square SEM, Joseph Hare is the big name. Okay? Joseph Hare is the big name. And if you can see here, this is a book I was mentioning to you called Multivariate Data Analysis. This is a 2010, 7th edition was in 2010, but now they have an 8th edition, which is 2018, okay? Which is a more recent one. The second book is this book called A Primer on Partial Least Square SEM. This is the first edition in 2014. Now we have another version, the second edition, which is 2017, okay, 2017. Try reading the first one before you move to the second one because they've actually removed some materials from the first one when they rewrote the second edition. So try looking at them, especially chapter 1 is really good. Okay, start reading the chapter 1. No? 2018, Joseph Hare came to USM as a visitor for a workshop. He was in Singapore and he said, I want to visit Penang. Can you arrange for me? So I arranged the workshop for 1 hour and then we had a good discussion. Some of my graduate students are quite lucky because they had an opportunity to take him sightseeing in Penang. This is my graduate student from Iran who is now a student in, he's working in graduate school of business. And this is my former PhD student who is now my colleague, okay? Who's now my colleague. Okay, the slides are already there in the folder, I think. Don't worry about the slides, okay? Just listen to the discussion later. I can share with those who did not get. Use boleh share dekat chat tak? Boleh chat ke?
Tak boleh Prof sebab saya bukan co-host.
Okay. Tak apa. Nanti saya try. Masa break lah.
Ya, boleh.
Okay. The more recent workshop I attended was with these two guys called Preacher and Hayes. This was in 2013. These are the two guys who actually criticized the method by Baron and Kennedy. This is Andrew Hayes and this is Christopher Pritchard. They came up with a method called bootstrapping the indirect effect. Okay? Bootstrapping the indirect effect. And in 2013, I traveled to University of Philadelphia, okay, to attend this workshop. This guy called Andrew Hayes, he developed a macro call process that you can add on to SPSS to do more advanced analysis. Okay, he's now extending the life of analysis using SPSS. In the US, what is happening is they move from SPSS to AMOS. Now they are moving back from AMOS to SPSS because we can do now more advanced analysis in SPSS like moderated mediation, mediated moderation. Okay? So those are some of the changes happening in the US. In Malaysia, we are now starting to move from SPSS to AMOS and Smart PLS. Okay? And also some extension you can look at to understand better the use of this add-on to SPSS. So this is Andrew Hayes. And this is Christopher Pritchard, who actually is quite well known for a technique called hierarchical linear modeling. This is where you have multi-level modeling. Later I will also show you data collection. One of the problems with data collection is we can have different combination of data collection. So this is, he's quite well known for a technique called hierarchical linear modeling. Okay? When I went to the workshop, during lunch, I had a discussion with Christopher Pritchard. He was telling me, I don't know how I can work with this guy because they are actually very opposite. Andrew Hayes does not believe in theory. He runs models which are very complicated. You cannot explain with theory. Whereas this guy called Christopher Pritchard, he does theory. Okay? He does theory. Yeah?
Saya rasa Prof tak ada soalan so far. Dia orang minta slide daripada saya tu email.
The more recent workshop I attended was on this statistics called Bayesian statistical modeling. 2020, during the MCO, I had the opportunity to attend this workshop with Roy Levy for 3 days. The workshop started at 9 p.m. and ended at 5 a.m. in the morning because we have a 12-hour time difference between Malaysia and the US. Although I attended this for 3 days, I'm still struggling to understand more about this technique called Bayesian statistics. This will become more important in the future. Okay. And the second Bayesian workshop I attended was with this guy called Eric Den Wagenmaker. Dan Dr. Yus ada 7 orang yang register dengan saya. Nanti saya send email apa during the break. Okay, so this is a workshop organized by Eric Den Wagenmaker in 2020. Now he's from Amsterdam. Okay, so this is a 2-day workshop which he organizes every August. Okay, so you can also plan to attend the workshop and see. Okay, when you are one of the things I like to highlight on this issue called passion. When you are doing something, you must be passionate with the kind of work you do. What I find is many people are doing this for other reasons other than passion. So that is where you have a challenge between the conflict between the other requirements and also the passion of working with research work that you are supposed to do. So this is where there's some debate happening now with the issue of promotion. Many people are doing things for the purpose of promotion, not about getting things done the correct way. So those are some of the debates happening in the literature. And you can see that proliferating with the kind of PhD students we are getting now. This is a discussion I had with a PhD student online. And the chat started like this. Hello, Prof. Ram. I'm a PhD student who attended your talk in some university in October. I have a question how to do when my Chromba alpha value for demographic data is low, 0.356. My Lakers scale Chromba alpha is high, reaching 0.9. Can I not report the Chromba for demographic data? And that's the question, no? Then my reply was nominal data, there's no Chromba alpha. Okay. Her reply is this. This is classic, right? Okay. The thesis I refer to from University Malaya, they reported Chromba alpha for demographic data. That's really worrying to me. Yeah. You have a Chromba alpha for demographic data. Something is not right? And the other famous question is this. Is there a reference to say that I don't need Chromba alpha for nominal data? Luckily, the person is not near me. Yeah? Okay. This kind of question should not be even asked. We teach this. I teach a course called research method at the undergraduate second year, first semester, and we teach them that when we do Chromba alpha is for Likert scale data. You can also do for yes, no question, but the analysis is not Chromba alpha. It is called Kuder-Richardson Formula 20. Yeah? And this is a university which we consider like one of the top universities in the world. They have a PhD student graduated with Chromba alpha for demographic data. This is really worrying, right? Okay. What I wrote here was, if I was the examiner, I would have failed the candidate, because basic understanding of analysis like this should be there at that level, which is the doctorate level. And if you see her reply, she got her PhD, by the way. So what is happening now is we have many PhDs who have graduated. They did many things wrong, and now they're telling their students, since they did it and they passed, the candidate should also be able to pass. That's a bad thing, right? Okay, you should also be clear. So understanding of research method and statistics is very important, not about only the analysis. What is happening is people are doing analysis without even understanding. That's a really not good sign for the quality of research that we are doing. Okay? And next, we will look at some developments in statistical analysis and structural equation modeling. We can divide the development of statistical analysis to 3 stages. The first stage was in 1900s, where we had correlation and regression. The second stage was in the 1950s, when they started looking at factor analysis and path modeling. Okay, path modeling. And the third stage was in 1970, when they started moving into this technique called structural equation modeling. Okay, so those are the 3 stages of development in statistical analysis. So in the 1900s, we had some gurus like Carl Pearson. So we should thank Carl Pearson because in 1896, he developed this correlation coefficient to see the relationship between 2 different variables. And then they started developing this into linear weighting, and they started predicting independent variable and the dependent variable. So that is how the development in statistical analysis started with Carl Pearson, 1900s. And in 1950, these are some of the names that became famous. Spearman is synonymous to Pearson because Spearman developed a non-parametric correlation version of the Pearson. So in 1950s, we also saw a guy called Sewell Wright, who is actually working in biology. He wanted to model simultaneous equation. So what he did was, this was the first structural equation modeling in 1921 to predict the birth weight of guinea pigs. That was the first structural equation modeling developed by Sewell Wright. Okay? And after that, what happened was we had this Swedish econometrician called Herman Boll. He's considered the father of structural equation modeling. He was the supervisor for Carl Joreskov. So Carl Joreskov went into a stream of research called covariance-based SEM. That is where the software called Israel was developed. And most of the software in covariance-based SEM are modeled along this line called Israel. Okay, Israel. Okay. And after that, it took them about 30 over years before we had a stream of research called structural equation modeling using variance-based SEM. Although it was there for a long time, we did not have software that was easily implementable. So that is one of the reasons why variance-based SEM took a long time to get launched. Only in 2005, when they launched Smart PLS 1, then only the software actually took off at a higher trajectory. Okay? So this is how you can divide your development of your statistical analysis. So we started with correlation, and then we moved to regression. Along the way, we also discovered factor analysis. First, we started with EFA, and then we moved to CFA. Now we have a combination of these two to become structural equation model. So in regression, we can only do one dependent variable, and in path model, we can do multiple dependent, multiple mediator, those kind of variables, and then finally we converge into a technique called structural equation modeling. So structural equation modeling refers to a diverse set of mathematical models, computer algorithm, and statistical methods that fit networks of construct to data. So it includes confirmatory factor analysis, path analysis, partial least square path analysis, Israel, and also another technique called latent growth modeling. They are all in this group of technique called structural equation modeling. So in structural equation modeling, what the software will do is it will examine the structure of interrelationship expressed in a series of equations similar to your multiple regression. Okay, what it means is like this. Here we have an independent variable called x and a dependent variable called y. The independent variable is measured with x1 and x2. The dependent variable is measured with y1 and y2. These are what we call as items we have in the question. So when we draw the model in structural equation modeling, the software will develop 5 equations. Okay, 5 equations. What are the equations? The first equation is x1 is a function of e2 plus x, x2 is a function of e1 plus x, y is a function of x plus e5, y1 is a function of y plus e3, and y2 is a function of y plus e4. So we have 5 equations that is developed in the algorithm, and the difference between your SPSS and structural equation modeling is in SPSS, we can only run one equation at a time, whereas in SCM, we will run multiple equations simultaneously. So that's why the term structural equation model. Okay, structural equation model. So in structural equation modeling, we have 2 kinds of variables. One is called the latent variable, and the second one is called the measured variable. What is meant by latent variable is variables we don't measure directly. For example, we have a variable called satisfaction. We cannot measure satisfaction directly. So what we do is we have several questions to ask about satisfaction. That is what we meant by measured variable and latent variable. When we do SPSS, all variable must be measured variable. That's one of the challenge doing analysis with SPSS. So structural equation modeling, we call them second generation technique because there's a slight difference between factor analysis that you run in your EFA and CFA. Okay, here we have a variable called X. We have a variable called Y. Variable X is measured by X1 and X2. Variable Y is measured by Y1 and Y2. In your data, you only have X1, X2. You have Y1, Y2. You don't have a variable called X. You don't have a variable called Y yet. What we will do in SPSS is we will take the average of these two items to become a variable called X. We will average these two items to become Y. Okay. And you have to do this manually. Okay. You have to do this manually. So this is why we call SPSS as first generation and structural equation modeling as second generation. In structural equation modeling, the items will still be here when you run the full model. Whereas in SPSS, once you calculate the score here, we call them the summated scores. And here also we call them the summated scores. The items are no longer useful. We will only analyze X and Y. That is the reason why we call them first generation and second generation. So when we take the average, what will happen is we lose information. Let's say you have a loading of 0.9 here and a loading of 0.5 here. You still take them as equal because you divide by 2. Okay, your average is divided by 2, right? Okay. Whereas in structural equation modeling, they will use the value called loading in the calculation of the equation. So that is why the result you get in SPSS and the result you get in partial least square, they will not be the same. Okay, there's no point comparing them. The result will be different. Okay, will be different. So those are some of the difference between your first and second generation analysis. So in first generation, we can also divide the analysis into exploratory and confirmatory. So in exploratory, we can use techniques like cluster analysis, exploratory factor analysis, and multi-dimensional scaling. For confirmatory analysis in the first generation analysis, we have analysis of variance, logistic regression, multiple regression, and confirmatory factor analysis. Okay, those are the divisions. In second generation, we have partial least square SEM, which is also called the variance-based SEM. And on the right-hand side, we have covariance-based SEM. Okay, these are techniques. Okay? These are techniques. Whereas we have a lot of software under this technique, we also have a lot of software under this technique. Okay, so I will explain what are those software. Huh? Yeah. Any question? Yeah, any questions?
Yes, Prof. You mentioned we cannot compare between first and second generation. And then the second generation, they take into account the factor loading.
Yeah.
So what is the implication if we take into the factor loading compare without taking the factor loading?
They will be different because the score you calculate here is based on these loadings and error term. Whereas the score you calculate in SPSS is, let's say the answer here is 3 and the answer is 5. 3 plus 5 divided by 2, you get 4. In SPSS, you do that, right? Average. Whereas here, they use the loading and also the error term to calculate the score. We call this latent variable score. So that is why the result will be different. Later, you can see the difference between the way they calculate score for AMOS and PLS also will be different. Okay? They will be different. Any other questions? So these are some of the differences between your first generation and second generation analysis. When we run factor analysis in the first generation analysis, we call them exploratory. Okay? Why do we call them exploratory is this. When you run factor analysis in SPSS, you take these two items, you put them in an analysis. The software will decide how many factors you get, and they will also decide which item goes into which factor. Okay. When we do EFA, we don't have a theory. Okay. We are actually guided by statistics called correlation. Items which are correlated will become one factor. Items which are not correlated will become another factor. And that's all the software will do. So what can happen in EFA is your X1 can go to Y, your Y1 can go to X. This is EFA. When we run CFA, we are actually telling the system X is measured by X1 and X2, Y is measured by Y1 and Y2. So Y cannot go to X, X1 cannot go to Y. So this is why we call them confirmatory factor analysis. And that's the basic difference between exploratory and confirmatory. So here what will happen is these two items will remain here or get deleted. These two items will remain here or get deleted. They cannot go across the variable, which is possible in EFA. Okay, which is possible in EFA. Yeah. Okay. The second difference between your EFA and CFA is in CFA we have this error term. We call them the measurement error, and we have another error term here. We call them residual error. Okay, residual error. Okay, this measurement error is now incorporated into your model. Where does this measurement error come in? You learn in your research method classes. Every time you do measurement, there are 4 sources of measurement error. Number 1 is the respondent. Number 2 is the instrument. Number 3 is the measurer. And number 4 is the situation. Okay, again, now, number 1 is the respondent. If you don't choose your respondent correctly, you will have some error from the choice of respondent. Number 2, we have instrument. If your instruments are difficult to understand, there will be some component of error. Number 3, we have the interviewer or the person who is doing the data collection. So if you are asking enumerators to collect your data, you need to train the enumerators. Okay, that's source number 3. And finally, we have situation. Where you collected the data. So if you collected the data during recession, there will be some factors happening. And if you are collecting them during a boom time, there will be some errors coming into the picture. So we have 4 sources of error. We are now incorporating them into the model. This is not possible in SPSS. In SPSS, when we take the average of these 2 items, we call them summated scores. We assume X is measured without error. That is the assumption in SPSS. Whereas now in structural equation modeling, they are already agreeing that every time you do measurement, there will be some error. Okay? So that is where these errors are incorporated into the model. This is not possible in SPSS. The third one is, we have talked about this, we call observed and latent variable. So in SPSS, your variable must be computed here, right? X must be computed, Y must be computed before you can run your regression. Okay? Whereas in structural equation modeling, you don't have to do the computation because the software will calculate a score for you called latent variable score and a latent variable score here. Okay? So that's the difference between the first and second generation. And the final reason why many people are moving to second generation analysis is when you have a model like this. let's say we don't have mediation. How many regression you need to run? How many regression you need to run? Anybody? We're talking about basic regression. We're not talking about structural equation modeling yet, right? Okay. Okay. When you have a model like this, you will need to run three different regression. The first one is x1, x2, and x3 to m2. This is your first regression. x1, x2, x3, and m1. x1, x2, x3, and m2 regress against m1. Your second regression. m1 and m2 regress against y is your third regression. So you have to run three regression. But the problem with this three regression is you are running three different models. Okay. First model is here, second model is here, and the third one. So this is the biggest criticism to SPSS. You are not running your model one go. You have only one model, but you have tested three separate models. Okay, three separate models. Okay. That is one of the reasons why many researchers are now moving from first generation to second generation analysis technique. Okay. Any question?
How about M1 to M2, Prof?
Ini dia sekali ya. Ini X1, X2, X3, and M2 together.
Okay.
All four together, not separately. If you run separately, you get different result. So we also have this discussion about EFA and CFA. In many institutions, I think in UMT also same. Many people like to do EFA and then follow up with the CFA. That's actually incorrect. You cannot do that. You have to decide whether you want to do EFA or CFA. EFA has a different underlying reason for doing it, and CFA has a different underlying reason for doing it. And here the guideline from this paper by Hulan et al. In 2018 says this. For papers not focused on skill development, use of both CFA and EFA is likely unnecessary. In general, use of CFA is preferred. So if you see now in most papers that you refer to, nobody does EFA anymore. Okay? Nobody does EFA anymore. What I see is only at the doctoral level study. This is because many of the supervisors are the older generation who were trained with EFA, so they get very upset if you don't do EFA. But that's actually statistically driven. EFA is statistically driven, whereas CFA is the one we work on theories. And when you write your chapter 3, do you write, I am not sure yet? Later in chapter 4, I will decide which item measures which variable. You don't do that, right? In chapter 3, you write, okay, variable A has 3 items from this author. Variable B has 5 items from another author, right? So this instrument has been tested many times before. So you should not be doing EFA anymore. You should always go with CFA. You should always go with CFA. Sarima, kenapa EFA and CFA?
Prof, how come SEM, this is in the conventional way. How about in SEM, they are not so emphasizing CFA and EFA, am I right?
In If you are doing SPSS, you can only do EFA. You can only do EFA, because in SPSS, you cannot tell the system like this, right? You cannot tell the system X is measured by X1 and X2, Y is measured by Y1 and Y2. No? You cannot do that. No? What will happen is you put all these items together, the software will tell you which item goes into which component. Correct? Okay. That's statistically driven, based on correlation. But here in CFA, you are saying X is measured by X1 and X2, Y is measured by Y1, Y2, right? This one we can do in structural equation modeling. We cannot do that in the first generation. Okay? That's why here we see, and we have been doing this actually wrongly. Yeah? I think, Sarima, your question is, I think in your institution, you are still doing EFA and CFA. Yeah? That's actually incorrect. No? You cannot do EFA and CFA with the same data. If you want to do EFA and CFA, your EFA must be a separate data, CFA must be a separate data. Or you can do what we call as split sample. You collect 400 data, you split the data 200, 200. 200 you do EFA, and another 200 you do CFA. That's possible. Okay? That's possible. Okay? You cannot do both EFA and CFA with the same data. That's not possible. That's not. Okay. Okay. In MOS also you are doing CFA, not EFA. Terima. Okay. Still, okay. When we do factor analysis, we have two types of factor analysis. One is the confirmatory, the other one is exploratory. Exploratory is done when you have no idea. You are saying, I'm not sure, I have 40 items, I want to see how many factors comes out. Then you do EFA. But here you already know how many factors you have, which item measures which variable, right? So you should not be doing EFA anymore. Okay, should not be doing EFA. Okay, next we will look at the two variation in structural equation modeling. The first one is called the covariance based SEM. Okay, the technique is covariance based SEM, and this side is called variance based SEM. Okay, these are the two techniques available. And the software to do covariance based SEM, we have Lizrel, we have Amos, we have M+, we have many more. For PLS, we have PLS regression, PLS discriminant analysis, PLS path modeling. These are all software that can do partial least square set. Both these techniques came from the same supervisor called Herman Wohl. Herman Wohl is a Swedish econometrician. He had two PhD students called Carl Gustav Joreskop and Jan Bern Lohmoller. Joreskop went into covariance based SEM by developing this software called Lizrel. And Jan Bern Lohmoller, together with Herman Wohl, they developed this partial least square. Okay, partial least square. So in partial least square technique, we have this software like PLS Graph. We have Excel Stat, Smart PLS. These are all available to do the same analysis called PLS regression. Okay? PLS regression. So here we have two variation which is available in structural equation modeling. The first one, which is called covariance based SEM, it has a different objective compared to the variance based SEM. What is the objective of covariance based SEM is you have your theory, you have your data. You want to see whether the data fits the theory. Okay? The data fits the theory. So this is where we have fit values AGFI, DFI, CFI, TLI in the first one. In the second one, which is called partial least square SEM, we are interested in maximizing the explained variance, which is the R square. Okay? R square. So here we are not interested in fit. So for those who are going into variance based SEM, you almost never see people reporting fit values for variance based SEM. But if you are doing covariance based SEM, you must always start with the fit values. If the measurement model does not fit, you cannot proceed to the structural model. So those are some of the challenges in this technique called covariance-based SAM. Okay, so those are the basic differences. Okay, why analysis in partial least square SAM and AMOS is different? Okay, here this is the reason. When we do factor analysis, we have two types of factor analysis. One is called common factor. The other one is called the composite factor. Okay, composite factor. What is the difference? Is like this. In common factor, we have two components of the measurement. We have a common factor here, common variance, and we have another two components called specific and error variance. Okay, so they will divide this into two, common variance and specific and error variance. So in AMOS, they only use this component, which is the common variance. In variance-based SAM, which is partially square, we will use total variance, not only this variance. So that's why the way they calculate the score is very different. Okay, it's very different. So here, in your common factor, you have a variable called the independent variable here and the dependent variable here. We have three items, x1, x2, x3, here y1, y2, y3. We have these three error terms, right? 1, 2, 3. These are called measurement errors. Okay. So when we develop a model like this, these arrows are called parameters. We have 1, 2, 3, 4, 5, 6, and 7 parameters to be estimated. So that is one of the reasons why in AMOS you need bigger sample size, because you need to estimate 3 error terms, 3 loadings, and 1 covariance. Okay. But if you do this in PLS, what will happen is like this. Variance-based SAM, they use composite factor. What is meant by composite factor is these error terms are not free to vary. They are already correlated. So these 3 error terms, you don't have to estimate, because the estimation is only for parameter 1, 2, 3, and 4. So that is the reason why in PLS, you can work with a smaller sample size, okay, compared to AMOS. Okay? PLS can work with a smaller sample size compared to AMOS. That is the reason. So when you correlate these error terms from the start, okay, your result will be different compared to this, right? Okay, to this. Yeah. Any question?
How small is the sample size, and then how large is the sample size?
For sample size, later I will show you how to calculate the sample size. But AMOS also, many people have what we call as ajaran sesat, deviant teaching, where they argue that you must have 200 minimum for AMOS analysis. Not true, not true at all. Let me explain this. You can also work with smaller number of samples if your models are simpler. You have only one independent, one dependent. You don't need 200. Even 75, you can still run the analysis in AMOS. But as your model becomes bigger, let's say you have 10 independent variable, 1 dependent variable, with many items, your sample size requirement will go up. So sample size is actually dependent on the kind of model you have, not fixed, not fixed. Any other questions on the difference between composite and common factor? One of the challenge with this common factor is, I think many people do this. You start with this model, right? Okay. And what you do is you start to modify. Okay? You put a double-headed arrow here, you put a double-headed arrow here, you put a double-headed arrow. This is what we call as modification. Okay? Modification. And in many workshops in Malaysia and I think many developing countries, many instructors will tell you it is okay to modify. It's actually not okay. If you really look at the literature, this modification that you do, they are actually not acceptable. You only modify if you have a theoretical reasoning. And there's no theory that will tell you you can correlate error term 1 and error term 2. Correct? Okay. So what will happen is you start to modify until you cannot modify. Okay. Sometimes you see arrows going everywhere. You cannot even see the drawing. And then they claim the model to be fixed. That's the first thing. Second one, what they do is they delete item. When the loadings are low, they delete. You begin with 50 items, you delete 25 items. That's really serious, right? Now you're saying my model fit. You have already deleted 50% of your model. You can safely throw away the model. Okay, but still people are passing with a PhD with that kind of practice. I find that very strange because many examiners don't understand issues of measurement and analysis. What they do is they read chapter 1, chapter 2, chapter 3, they skip chapter 4 and then go to chapter 5. In quantitative research, if your chapter 4 is wrong, I don't have to read your entire thesis. It's already failed because if you fail at your analysis, wrong analysis, chapter 5 is wrong, right? So you have 2 out of 5 chapters already wrong. That will be a major correction. In USM, anything to do with analysis will be a major correction. Okay? Will be a major correction. That's the minimum. We can go until reviva also if the model is wrong. Okay? If the chapter 2 modeling is wrong, chapter 4 is wrong, and chapter 5 is wrong, that will end up in a reviva. Okay? In a reviva. So think about it. Okay? So I will give you some literature to support why you should not be modifying them. In the software called AMOS, we have a very bad button called modification indices, MI. That MI is the one many people use to modify the model. And what they are arguing is the software gives you how to modify. The problem with the software is they don't understand theory. They only understand statistics. So what they're trying to do is they are trying to minimize the chi-square. Okay? And they will tell you this. Correlate this error term with this construct. Okay? This is also will be suggested by the software, but this doesn't make sense, right? Error term of your independent variable correlated with the variable from the dependent variable. That doesn't make sense at all theoretically. But still people are doing because the software gives you some suggestion. Okay? So these are some of the literature that tells you you should not be doing that. No? And this is a paper that you should read carefully. By Green et al. In 2016 in a journal called Organizational Research Method. And what they wrote here is correlating measurement errors in CFA-SEM is almost always bad practice. Okay? And this is what everybody is doing, right? Okay? The UMT, dan ramai cakap lah, ini Green et al. Yang cakap. Correlating measurement errors in CFA-SEM is almost always bad practice. This is from the paper by Green et al. This is a paper in 2017 written by Hare, and he mentioned this. A generic measurement model is a psychometrically sound representation. That means no correlated error variance terms. Generally, if correlated error terms are necessary to achieve good fit, the measurement is flawed. Okay? The measurement is flawed. No? So this is the paper by Hare et al. In 2017. Goodboy and Klein also mentions this issue called modification. Yeah. The temptation is to add the part to the model with the greatest modification index value. That is also significant. But such a re-specification may have little, if any, theoretical rationale, adding many error correlation because of MI. This is actually not recommended also. Okay. And we also have a term called cherry picking. When they report models in AMOS, they only report the nice value, the values that pass the cutoff value. The values that did not pass, they don't show. That's one of the practice called cherry picking. This is by Good Boy and Klein. And the more recent one is in 2020 by Davitas et al. They wrote this about modification indices. Okay. So if you start modifying, what it happens is you are going into data-driven models that cannot be theoretically justified and would rarely replicate on different samples. Okay, so this is some of the things which is already there in the literature, but unfortunately, this is not exposed to many researchers beginning in their career. So what they think is you can do modification, and that's a predominant way of getting your model to fit, which is actually what we call as hacking and hacking. This is a famous statistician called Ronald Coase. What he wrote here is, if you torture the data long enough, it will confess. Okay, so if you start deleting item, you start modifying your correlation, what will happen is finally it will become significant. Okay? So these are the two terms now being discussed in the literature called hacking and hacking. What is the difference is hacking is you start to modify your model. To pay